How we doing? How we doing? Hopefully my audio's good. Ooh, why is my window capture so weirdly sized? There we go. Hopefully that looks okay. So I think they're both live. I think I'm live on YouTube now. And Twitch. Yeah, we good. We Gucci. Okay. Jenna, if you're watching, can you read that? Or do I need to zoom in more? So, I want to do something a little bit differently. I've been wanting to do this for a long time, but now I can actually have an evening to like work on it some. I like playing around with Arduinos and like lights and wiring and like temperatures and apps and stuff like that. So what I want to do is, let me bring up an abstract here. Create a mini pilot plant that runs off an Arduino controller. Uses an app to monitor reactor data. I figured that'd be kind of cool because I've used an app before. So mini pilot plant runs off our Arduino controller. We use an app. Has the below data. We want agitator RPMs. What up, Hattie? We want agitator RPMs. We want jacket temp. We want reactor temp. And probably starting out, that's probably a good start. That's going to be quite a bit in and of itself. So what are we making? We're going to get there. I want to make a mini pilot plant. Like, I want to 3D print like a little baby reactor and like room for an agitator, room for temperature sensors and all that stuff, and have it run off an Arduino and have a phone app that can like monitor, like I can pull up the phone app and turn the agitator on and off. I can start, you know, the water flow and stuff like that. That's kind of what I'm thinking. So that's kind of where I'm at right now. But I'm like, this is literally just like, I was thinking about this like when I got home and was like, I have an evening to do it, so I want to work on it some. So let's see. Patriots still on for Falcons. Oh, okay. That's not what was important. Do I have a printer? I do have a 3D printer. It's actually right there. So I'm going to be like 3D printing like as many of my own parts as I can and just kind of try it out and like see where we go. Something completely different than what I normally do, but I didn't really feel like gaming. And I was like, what can I do? And I was going to do it anyway. So I was like, I just want to work on like this. And if I stream it, then I'm probably like more like dedicated to actually doing it. So parts, needing, designed, and printed. We need main reactor. We need reactor jacket. We need nuts and bolts. We need a reactor top of some kind. A jacket top of some kind. Depending on how in depth I want to make this, we probably need a water reservoir. Reservoir? That's definitely not how you spell reservoir. Why do I not have spell check? Okay. Anyway, so we need a water reservoir. I want like a water tank that can feed down to the jacket, cool off whatever I have inside the main reactor, which would probably just be like hot water or something, and have cold water going through the reactor jacket and then like looping back up to the top of the tank. So we need a water reservoir. Technically, we need piping of some kind. I don't really know what I'm going to do for piping yet. Do I need a pipe rack? We need a base of some kind, because if I want to make this like a little set that I can like pick up and sit down on like a table and like turn on, because I want to eventually like show people. I'll be like, oh, this is something I made. It's pretty cool. So main reactor, reactor jacket, reactor top, a jacket top, some kind of water reservoir, but like a tank with like some kind of piping coming out. Maybe pipe racks. That's probably going to be a bit much. A base. We need nuts and bolts to secure the top to the reactor and then the top to the jacket. I need to 3D print an agitator that is going to go inside the reactor itself, and as I turn it on the reactor, it's going to spin to like mix. I want to be able to mix. What else do I need printed? I need a Arduino case. Why can I not spell Arduino all of a sudden? Arduino case. Some kind of battery pack holder. Battery holder. What else could we design? That's probably a good idea, because once I get this down and I get it in my head, I'm gonna go into and make like a sketch here in a second, and then after I do the sketch and I get it like somewhere I'm comfortable with, I'm gonna go into CAD and start like doing some like small design stuff. Okay, so electrical components. We need an Arduino. We need wiring. We need temperature sensors. I need some way, something to measure RPMs. Let's see, what else? We need a Bluetooth module. We need an Android phone. You know a lot about nuclear plants and how they're set up or what? I do not. A switch? I do need a manual switch, don't I? Manual switch to turn it on. But I want to be able to turn it on like from the phone. Bluetooth module. We need a motor. We need a water pump. I know about like plants in general, generally how they're run, specifically nuclear, no. Water pump. We need LED lights. because I want to have a red, an orange, and a green. So like orange is going to be like it's starting. So red's going to be it's off, right? And it's safe. Orange is going to be it's kind of, you know, it's in a shutdown or startup process, and then green being that it's on and running. So how big do I want to make this thing? And then let's do app needs. Start water flow. Start agitator. Some kind of timer. Because I want to be able to like monitor how long it's been running. So we need to start water flow, start agitator, timer, monitoring. We want jacket temp, reactor temp, RPMs once I figure out how the fuck I'm going to do that. Time running. Don't think I can actually do this, but like battery level, that's probably not possible. That's probably like too far. Because this is something I've done in the past, and it's been years and years and years ago. This is like right before I graduated college that I had done something similar, but I didn't have a 3D printer to make it like official. So I'm gonna have to redo all the wiring. I'm gonna have to remember how to do all the coding and shit. So this is gonna be an adventure for sure. Okay. So I have it in my head, I think, of kind of how I want to do this. So now we're going to go to Draw IO and we're going to start drawing shit. Nothing, I'm not going to measure anything out yet, but I know that I want like a base, right? And then I want some kind of like control box to house all of my like controls equipment. So this is gonna be like a mini MCC controls. I want that like on the side somewhere. Then as Jenna was saying, we need like a on-off switch here. Next to the controls. Need a water tank of some kind. I don't know why I can't spell reservoir. I'm just going to call it water tank so I don't look like a fucking idiot. So we need a water tank. Need a pump somewhere. And pump housing. Water pump. Housing. I don't know where I'm going to put that yet. And then what else could I do here? I mean, I could make it more complicated, but I think for like a first pass of just like proving the concept. Now, if I wanted to add like the ability to add in reagents or something to a reactor, we could get there. But I think like for just a first pass, we got to have the cooling water going to the water pump housing, the water pump housing to the reactor jacket. So this is going to be the reactor jacket. And then inside the reactor jacket, we have to have reservoir. Yeah, thank you. Apparently I'm just dumb. And inside the reactor itself, we have the reactor. Actually, let me do it this way. I don't want to do a top-down. Yeah, I can do it this way. That's fine. So you got reactor jacket. And then we have the reactor itself. Here. Then we need some kind of agitator. It's a bit big, isn't it? Need these to be a little bit smaller. And that's going to be our agitator. There we go. So this is kind of the main design here. I guess I can get rid of this because I'm not doing top down. Sure. Okay, so we're gonna have a water tank. Then we're gonna do like a water pump housing. How does this look, Jenna? Do I need to zoom in some, or can you see it pretty easily? Like, how's the quality of this look? Like, can you read everything I'm typing there? Or should I zoom in some? Because like to me it looks great, but I'm looking over at the screen and it looks like it's a little small. Looks good. You can read it. Everything looks clear. I mean, I can always like zoom in some too. So yeah, this is kind of what I'm thinking. Maybe move all this down some, so I got like more room. And then this is clearly going to be like the base plate of some kind. Right, so now, how do I want to connect everything? Where does the batteries go? I just have it going right here, like in this little controls box. Like inside of this is going to be like the Arduino and the Bluetooth module, the battery pack. Like all of this is going to be like in a little baby building. That's kind of what I'm thinking. So we would have the feed on the top of the tank. Need arrows. hate crooked lines. What's the canoodler? What is that? So you got water. This is going to be the recirc line, right? It's going to go from the reactor jacket to the water pump. I guess I need technically 2 water pumps, don't I? Well, no, I can just have like this coming in here, and then it's going to go around and back out here. Or like out here somewhere, or maybe at the bottom. Like have it come in the top, and then go out there. I'll have to figure that out, where I want the water to come in and out of that, because that's where I'm going to have to like design it to be. And then I need one more. Feeding into the jacket. I need like little baby arrows. I need it to be like arrows across. I don't think it has that. What does that do? It does not give me arrows, does it? That's not what I meant to do. We'll do it this way. Okay, so the idea is that the water pump is going to turn on, right? And it's going to feed the water into the water tank. Actually, we'll start here. The water pump's going to come on. I probably need a pump right here. I probably need 2 pumps. Just to like give it like a good chance of actually working, right? So this water pump is going to turn on once we turn the on switch. It's going to pump the water out of there into the jacket. It's going to rotate around. It's going to come in the top, go down here, like cooling the vessel, hopefully. And then this pump will be also on, and it'll be pulling it out of the jacket, recircling it back into the top of the water tank. So that way it's always cold water at the bottom, mixing here to hopefully cool it down by the time it gets back to the bottom. And that should give me a decently cold reactor jacket. Because I could even put like ice in there or something. You know? So that's where my water is going to go. So what do I need for this to happen? I don't have a way to open valves and stuff. Eventually I think like maybe eventually I would do valves. But I think for simplicity's sake, we're just going to say this is all hooked up. And if it's got water in the line, it's got water in the line, right? And it's not going to transfer heat as well until the water's moving. So electrical lines. What do I need? What do I want for dinner? I have no idea. What do you want for dinner? So electrical lines. We've got the agitator Going back to the MCC. It's not level at all, is it? It can be black, sure. I really don't care. I mean, I'm kind of open to whatever. So that's an electrical line. We'd also have a line going from this to the on-off switch. Culvers? Are you gonna go pick it up? I could go for Culvers. So you don't want to cook is what I'm hearing. You can come in here and talk to me, you know that, right? I also need power to pump. Both pumps, actually. So I need power too. Yeah, it's like Steak and Shake. It's like burgers, ice cream, fries. We tried Rita's. Oh yeah, dude, Rita's fucking slaps. That stuff's amazing. I fuck with Doritos. So now the question becomes, I need to put in my temperature probes and stuff too. Probably do it right here at the outlet. No. Probably do it maybe in the middle. And we'll call this TI 01. And then we need another one inside the reactor. And we will call that one TI 02. We'll make that green. Okay, so we got controls. I need to change that color, don't I? So we got green wire. This is going to be some kind of analog signal coming in as well. So it'll be AI TI01 for analog input temperature instrument 1. Be that one. This one will be a blah 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 2. And once I figure out what actual analog spot I'm going to put it on, I can update that. I can even do it right here and do AXXX. AXXX. This is going to be a digital. This wiring is a digital wire. This will be DI A01. Actually, that's a controls wire, not a power wire, because it's just a little servo motor or whatever. There's no actual power to it. This one has its own power and a controls line. That means I need to run a new controls line for on-off switch in each of those. Easy peasy. We can do that. That's green. This will be digital input because we're receiving the signal saying that it's on. DI on 01 is going to be our tag for that. Yeah, that should work. Then we need this one. The pump itself, I don't know how we're going to do this one or what input this is going to be yet. So I'm not going to give that one a tag yet. This one, same thing. We don't know what kind of input that's going to be yet. So I won't give that an actual input name, but I know this is going to be a digital input because we're going to have a manual switch that they can turn on. I know these are going to be analog inputs because we're going to be receiving a signal in from these temperature sensors. And then this one's just going to be a digital input as well. Actually, no, this will be a digital output because we're going to be sending it a signal to turn on. So that's a digital output. So easy cheat sheet is output is like you're throwing a ball. Input is like you're catching the ball, right? That's the easiest way to remember. For me anyway, between like an analog input, analog output, a digital input, a digital output. So yeah, I think this might be my base. Let's see, we've got controls for the water pump, control for both water pumps. We've got our water tank, we've got our hosing for the water itself, going into the jacket of the reactor, pumping down, coming out from the reactor, getting recycled back in. So that's good. We've got 2 different temperature sensors here. One for the jacket itself to say like what the temperature of the jacket is. And then we've got one for the temperature inside the reactor itself. And those are analog inputs that the Arduino is going to be reading and sending a signal, which we need to have as well. Just have this put out here, like a dotted line or something to say that it's going to like a phone. Because we're going to have Bluetooth up to a phone. And we will call this HMI 001. Because why not? So yeah, I mean, that's pretty much it for the concept. This is kind of the concept I'm thinking. Now I just gotta like start thinking about a size. What up, Germ? How we doing, big dog? Is that clear on YouTube, Jeremy? Like, is it nice and easy to read? Because like I'm using the restream and I went back and looked at the, like when I streamed Elden Ring the other day, and it looked pretty good. Like it looked, oh yeah, it's really clear. I've noticed like the stream quality on YouTube is so much better than Twitch. Like you get a higher frame rate too. Like if you watch the gameplay like VOD from when I played Elden Ring, dude, it's like a smooth 1080p 60. Like it's nice. Yeah, so this is kind of what I'm thinking of doing. Does anybody have any questions before I continues? Can you, so you can read it, Jeremy, like fine, like you can read all the names and stuff, like I don't need to like zoom in some more? You love Rita's? Dude, Hattie, Rita's is awesome. I got like cotton candy unicorn or some shit, and like cotton candy like shaved ice, Italian ice, and then like strawberry is like strawberry unicorn, like Italian ice cream. Dude, it was amazing. Yeah, I got a gelati. That's what it was. It was so good. Like I was really on the gelati train. Like it was fantastic. But yeah, so I think we just need to title this bad boy. And we got large. Yeah, we did get large. Yeah, I don't have you full screen and I can see everything. Hell yeah. That's what we like to hear. So we would call this mini pilot plant sketch rev.0. And I will give it a date just so I can keep up with what the fuck I've done. Oh wait, say the 14th, really? I get cherry ice and vanilla custard or Swedish fish with vanilla. I get large every time. Bro, that's good stuff. I don't blame you. Like, I fully understand why you would get like a large. It's so good. So yeah, this is kind of what I'm thinking. Now, like I said, the problem is figuring out how big to make everything. Right? That's going to be our next step here. Is sizing. Because the Arduino itself is relatively small. So, I mean, I don't think I need to make this stuff huge. And the base plate itself over there is not that big. So the question becomes now, how big, like dimension-wise, can I make this bad boy? You know what? I'm just going to do it anyway because I'm thinking about it. I'm going to name stuff. This is going to be Pump 001. I am not gaming tonight. No, I'm going to be doing this all night, I think. I haven't really like had the urge to game. And like since I got home, I was just like You know, I kind of want to, like I was talking to Jenna about it and was like, I kind of been wanting to do this for a while. And so I just figured I would do it. No, not an extra text box. Tank. One is going to be the water tank. We'll name this R1. RJ1. Finally, A001 for agitator. What in the hell is happening? This is a war zone? What up, Del Chapo? Oh, that's Big Poppy. Big Poppy! How we doing, Big Poppy? Does it say it's Warzone? I'm pretty sure I have it set to not be Warzone. No, yeah, I'm co-streaming on YouTube as well, Hattie. Name change, buddy. What up, dude? Haven't talked to you in forever, man. How you been? Okay, good. I was gonna say, like, I don't think I have it set to Warzone. Like, I thought I had it as like science and technology. I didn't know if I should do science and technology or like crafts or some shit. I didn't really know what to put it as. So I just kind of like named it science and technology. Because I'm technically using like a 3D printer and Arduino. So I mean, that's kind of science and technology. What are we learning? I'm eventually going to be relearning how the hell to program in Arduino. Because I have not done that in forever. And I'm going to be designing most of these components, including the nuts and bolts and stuff. Like Jenna found these nuts and bolts, so I'm going to take them and like edit them to whatever size I need to kind of piece everything together. So I'm going to print the base plate. Maybe that's what I should start with, is like designing the base plate, because that's going to be probably the easiest thing to design, right? It's going to be like we build our base plate and like that be the size I can work off of. But the question then becomes, how thick of a base plate can I do that if I have all of this stuff on it and I want it to be like mobile, right? I want to be able to like pick this thing up and move it. Oops, sorry. I want to be able to pick this thing up and move it. If I do like, you know, a really small base plate, is it not just going to like snap on itself? Because that's kind of what I'm worried about. Is that it's just going to like crumble on top of itself. But I don't know if it actually would or not. To build what? I want to build a mini like pilot plant that has like temperature sensors and stuff on it that I can monitor. Like I want to have like a phone app that I can like turn a pump, like turn the water pumps on, turn the whole thing on, and I can like see the temperature inside the reactor and see the outside reactor jacket temperature. Oh yeah. What up, Hattie? See the reactor jacket temperature and stuff all on the phone. And I can like turn it on and off, and I want it to be like Bluetooth, and I want to be able to like have it mobile. For a weed plant? No, like this is just like, I'm literally just a fucking nerd and thought this would be cool to like build. Like I've always wanted to build it, but I didn't have like a 3D printer and stuff to actually make the parts to build it. And now I can. Nah, I don't smoke weed, bro. I get tested for that stuff too much. I get tested every like 6 months to a year for all that stuff. Patent pending was my idea. Should I have like a watermark on this? I don't have to smoke it. I mean, that's true. Yeah. That's just not my jam, you know? Not my vibe. So, Jenna, what is the name of the software? Like Biggie, don't get high on your own supply? Exactly. Exactly. Now you're using the old noggin. Is Jenna still here or did she leave already? I don't think she texted me or anything. I need to ask her a question. So let's go ahead and become my sugar daddy. I need you to be my sugar mama so I can just do this shit all day. That's what I need. I can't save as yet. Okay, so we're just gonna do a rectangle. That is not what I want to do at all. See, this is where the fun's gonna be. Is I need to know how big the base plate is of my 3D printer to know how big of a base plate I can even build. And I don't know the size of that fucking thing. Will the CUDA software tell me? You can measure it? Yeah, but this is in millimeters. Use my phone? Nah. I'm not that talented. It should tell me in the Cura app. Because like that, you know, it's set to like a certain distance or whatever. The question is, how the fuck do I measure this? Like somewhere in the settings, I have it set to 230, 230, 260. Is it an iPhone? It is an iPhone. Where'd it go? There it goes. 230, 230, 260. So I need to be a little in from that. Oh, I already fucked up, didn't I? Why can't I edit this? Aha! We learn, chat. We learn every day. Search measure in the already downloaded apps. It'll pop up. You can use your camera and pinpoint point to point, and it'll get you a measurement. Yeah, I mean, I could do that. I've done that before, and it's actually pretty good. But like I said, like the software itself just tells me like what my dimensions are of everything. So 230x, 230y. So if I did 220, if I did 220 by 220, that gives me 10 millimeters on each side. Right? And that gives me a square base plate. Do I want a square? Is that square? Oh, I want to move. How do I move? And then we want to extrude this bad boy. Okay. How thick do I want this? How's 20 millimeters look? Half inch at least. Yeah, but what's 20 millimeters to inches? That's 0.7. Okay, so that's 20 millimeters apparently is like, that's 0.78 inches. Like, I think 20 millimeters would probably be fine, right? Why ain't this guy say hi back? Because he's a bitch. I said I wasn't gaming. He was out. He was like, I'm gone. Deuces. That's why he didn't say hi back. Also, Hattie, if you could do me a favor and like that stream, big dog. I need to fillet some edges here. Because we want it to be not sharp and like pokey. Trying to select you. There we go. Are you going to fill it in solid? Yes. I have a feeling you're going to tell me this is going to be like so much material. Should I not? I'm guessing I probably shouldn't do 0.78 inches solid. You mean report, right? Yeah, no, not report. Not report. Report is bad. That's nice and smooth. Okay, so now it's nice and rounded. No sharp edges. Okay. So you're saying if I fill it in, like, because I mean, if that's 0.78 inches, that's quite a lot. So what's a ½ inch in millimeters then? It'll be stronger, but it'll probably take a day or more to print. You think so? What about 10 millimeters instead of 30? So that's 0.4 inches roundabout. Like that should be, I mean, this stuff's not going to be heavy. I need to figure out how to re-edit this shit. Properties? Nope. You really think it'd take a day to print? I just don't want to make it too thin, because if it's too thin and we like, if I make everything ½ inch is like 12 or something millimeters, 12 or 13 millimeters. Yeah. Why can't I edit you? Units, millimeters. How to edit extrusion. Select the extrusion and the project bar, click modify. I don't even see a modified button. What? On the properties palette, change the visibility, material, or subcategory. Does it give me an estimated time? It does give you an estimated time. So like once I make this, I can export it to that Kira software, and it'll like go through and do its like math and be like, okay, this is how long it's going to take me to print. How the fuck? Figure? No. Anyone out there that knows how to do this better than me, know how the hell to edit an extrusion? That's like the only way I could think of to do it. What am I trying to do? I'm trying to edit this extrusion when it's already done, but it doesn't seem to want to let me do that. It's just like, oh, you can't do that. At everybody. Min PP. Min PP. Min PP base. Actually, I need to save that somewhere else. Okay. And then I need to export this guy. I believe it's STL file, Jenna, that it's got to be. Export. Okay, and then we go to this guy, and we go to open file. Looky there, looky there. Now let's see how long it takes to slice. 10 hours and 49 minutes. Ooh, and I don't think that's even completely solid, right? How do I make it solid? Unless it's already saying that's solid. 10 hours is solid. Okay, so it's doing that kind of pattern. I mean, that should be fine, right? Change it to 80? $23 hours. Ooh. What about 50? Let's do 50. 17 hours. Holy shit. 17 hours is insane. The thing is, I don't want to reprint this, right? It's like I want to get it right the first time. So if I print it and it's like super flimsy, it'll just snap in half. Told you? Yeah. I don't know. I don't know what I want to do here. What about 30% density? That looks kind of strong, right? 14 hours? I'll take that. Bold strategy, Cotton. I actually didn't even hear that play. I don't know if that went off for you or not. Let me see if my sounds work. I don't hear any sounds, actually. I mean, I'm good with that. 14 hours for it to be hopefully completely solid, you know? So let me go base, 30%. Field density. That way I know for like the future. Okie dokie. So the base is done. And I said it was 220 by 220 by 10. So let me make a note of that as well. 220 x 20 x 10. Okay. Now I need my calipers and stuff though, because now I got to start measuring shit. New design. I'm gonna run to the bathroom and stuff anyway. So let me run to the bathroom and then I'll get my calipers and stuff and we'll come back and I'll start like thinking about how to measure this shit. So I will BRB in just a couple of minutos. Okay. Sorry about that. I'm back now. I was getting food situated. Okay, so I'm gonna actually go ahead and start this print. I got the disc, but I need the. Also did leg day like 2 days ago, and I can barely fucking walk. My thighs hurt so bad. So don't judge my walking. Oh God. Go ahead and get it auto leveling. Then once it's done auto leveling and preheating, we will start the print on this guy and we'll move on to measuring shit. Drive F as CFFFP min PP base. Okay, easy enough. Oh God, my legs. So right now I'm waiting on it to heat up. And then once it heats up, it's going to start leveling itself. Shorts too. I feel like my shorts are constantly falling off. Some of the things that we need to measure. I don't know if my audio is even getting picked up right now. Is we need to measure this guy, which is a RTD temperature probe. It's a three wire temperature probe. So that's one thing we got to measure and design for here in a second. Something else we got to measure for is we have to measure for this guy, which is our Arduino board, for some kind of housing for this guy. Safe housing, so if it does have a leak or something, we don't lose this. Because that's the brains of the operation. Motors. I have a little baby motor, servo. I gotta go get a big one here in a second. We also eventually could incorporate like a pin pad, right? Where it's like you have to like punch in like a certain code. That would be pretty sick. We might get there one day. All right, it's leveled. I just gotta wait on the filament to heat up, and then we can officially start printing. I'm gonna run and grab an actual servo motor real quick so we can measure that as well, because I gotta know how big to make like the agitator like housing for it, and how big to make the agitator piece that goes up on it. I'll be back in just a second. Okay. Ooh. I am back. So I had to go to the garage to get this motor, which is a very large, well, larger servo motor. And the question we're going to have to figure out is, I know you can't see that, but that's like teethed, right? And I got to figure out how we can print something that'll hook on to that teeth, those teeths, tooth, whatever, and have the spick come down and be like the agitator. But it's got to be able to fit this guy. So that's something else we're going to have to figure out too. So we've got that printing. So what is the next thing that I want to make here? Okay, we're on the XY plane. That's the plane we want to be on. Let's go back to our document. Let's see, base. Probably need to do the reactor jacket next, because that's going to tell us how big our reactor needs to be or can be. So what holes do we need in a reactor jacket? If we go back to our design here, we need 1 hole, 2 holes, 3 holes. The best way to do this might be to have this level with this guy and have like one big lid with all the holes in it, and then just have this on like stilts. So that way it's still suspended in the water. Like have it secured to this guy somehow. Like maybe hot glue it or something, maybe. Or I could design it all as like one jacket piece. Maybe that's the better option here. Also, now that we have measurements, let me put some measurements out here. 220 mm. Oh. (10 mm) z-axis. Okay, so I got that documented. So I definitely want like a cylinder, because that'll help with the water flow. And this is the XY, so we're looking down on it. So let's think about some dimensions here. We got 220 millimeters to play with. That is going to take so fucking long. Okay. What's the max this goes to, actually? So the max this goes to is 155 millimeters. We're clearly not going to do a jacket that big. So let's look at some wall thickness. Zero that out. I would say, like, this is really hard to see because I don't have the best camera in the world. Like, that's 2 millimeters. I'll hold it up so you can see. I would say that might be a little thin of walls, just because of having all of this stuff to go in. So maybe, what about 4 millimeters? I I think we'll do 4mm thick walls on the jacket. So then that makes, what do we make the 230? So if I did 80, what about 80? So this is 80. That would be like 80 plus, you know, the circumference of the, you know, the wall thickness for the outside jacket. I feel like that still might be too small. So maybe we go 100? So if we did 100mm with 3mm wall thickness. Let's try that. Hundred's quite big. And then how tall do I make this bad boy? Should I do 150? Maybe I'd do 100 height? If I did 100 diameter and then 100 height. Let's do 125. $125. Wall thickness, we want 3mm. Is 3mm too thick though? What about 2mm? Let's see what 2mm looks like. So if we did, the only thing I'm worried about is if we do 2mm thickness on the walls, I'm worried about, like, as I'm pulling temperature sensors and stuff in and out, that it's going to, like, break. I think 3 is probably the way to go. So we'll do 3mm thickness. And then we need to flip it. Do bottom. Need to do a sketch on the bottom. Create a sketch. And just make the bottom whole. Okay. Actually, no, I need to do 2 off and 2 off, right? I need to do 96. No, oh, I did 3. Fuck, I'm sorry. 3 and 3 should be 94. And then we want to extrude that. In 3mm. So now all the walls are 3mm. And it's not hollow on the inside anymore. So this is going to be our jacket. is kind of what I'm thinking here. So let's save this. This is going to be reactor jacket. Rev 0. Okay, so then let me go in. We did 100 millimeter diameter. 100 mm diameter, 3 mm wall thickness, x 125 millimeters. Z-axis. Okay, so we're documenting as we're going along, keeping up with what we're doing, right? Okay, so what all do we need to go into this guy? I want it to be level. So whatever this ends up being, it needs to be 125 minus 3, so 122 tall for the reactor itself, if we were going to do the reactor on the inside. Which we could technically do and just have it print off as one piece, but I'm kind of worried about that not working. I would rather just add some stelts or something to this guy and have that be kind of what we do. What is that, the tower? This is just the reactor like jacket. So this is what's gonna be like where the water is like circulating in, and then we got to design something to like go inside this, which is gonna be like the actual like vessel that like materials would go in and react. So what I'm trying to think of now is like where to put holes for the temperature sensors and where to put holes for this guy. But if I keep it hollow on top, I don't have to worry about holes right now. I just need holes for these two and where to put those. That's the only thing I got to figure out now is how to put these holes in and where to put the holes. And more importantly, what size to put the holes. So we've got this guy. And Hattie, you might know this because you do this kind of stuff on the daily, right? Like in general. So this is clearly like where the temperature is measuring. Should I have it be to pop in to the side of the reactor, right? To actually go into the reactor vessel, up to the protective piece, the like piping or the wire protector, or should I do it just to the tip of the stainless steel? Oh, you know what? Something I didn't even think about. We've already found a design flaw. This is the only size I have. So this needs to be able to get into the reactor jacket and into the reactor itself. How can I do that? Do it to the back of the stainless. Ours usually put in wells, if you know what I mean. Yeah. That's what I was thinking. So to the back of the stainless is like right at 35 millimeters. The problem is this whole distance across here is now 100 millimeters. So 35 millimeters. Is that right? 35 millimeters? Yeah, 35 millimeters. So if we have issues with the probe, we can pull the probe out without having to valve anything out. Yeah, see, that's what I need to figure out is how I'm going to do this. Is like, do I just like make a hole and put a rubber ring in, and this just goes in the rubber ring and the seal is like right around it? And that's kind of like, it's just stuck in there pretty tight with a rubber ring so it doesn't leak. That's going to be a good question of like, what kind of housing am I going to have for this guy so it doesn't just like flop around and get like broken or something. So 35 millimeters minus the 3 for the wall thickness automatically leaves me 32 millimeters. I'm going to have to make this circle smaller. Yeah, this can't be 100. This is going to have to be... So if I do 75, this gives me 32 minus 35 minus the 3 is 32. So that gives me 32 millimeters to get in to the jacket and into the reactor. Make a hole in the cylinder and then we make a separate well. That's what I'm thinking. So then this is now 75 minus 6, so 69. Nice. So now we have 75. And I can't do 125 meters tall either. $75 millimeters. I'll have to do 75 there as well. Then epoxy or silicone. Yeah, that's what I'm thinking. Or like get like a rubber washer, or like a rubber O-ring or something. That way it has like a nice like seal to it. See, I need to edit this extrusion. Still haven't figured out how to do that. How do I edit this shit? Yeah, that'll work too. Yeah, that's kind of what I'm thinking. How do I do this? In the drawing area, select the extrusion. Okay. Select the extrusion. Click modify. Modify. Element tab. How do I do this? I'll do it here. Ha-ha! I am a fucking genius! Okay, now we're back in the game. Okay, so you're saying make a hole in the wall. Sweet victory. Yeah. Okay. So we go back to my sketch. The best place to put in the temperature probes. I would say midway up the vessel for now. So around 35-ish millimeters. I would like to do a new sketch, please. That is exactly what I want. Create sketch. So that's 75 tall. How full is it going to be? I'm going to try to make it pretty full. So that way, like, it has good suction. Like, I don't want to have any cavitation in like the little water pumps and stuff. So now I got to measure the thickness of this guy to see how wide the hole needs to be. Make sure we're zeroed out. We are. Six millimeters. So we need a 6 millimeter hole. That's 50, that's 75, 50, 25. So I would say like right here somewhere. If you want to get handy, you could drill it as well, but whatever works better for you. Well, I'm trying to do it like as much as I can, like doing the design itself. So 6 millimeters. Because I mean, yeah, I could just drill the hole. 6 millimeters, 6 millimeters. Finish the sketch. We want to extrude both of these. We want to go 2 sides. Cut. I'm going to say 6 and 6. That way we know it's got holes. Beautiful. We like that. If it don't work, a drill is an option. That's all. I don't know how these printers work. Yeah, that's what I'm thinking. By the way, I don't know if you can see that or not, Hattie. Let me switch to full screen here. I don't know how good my camera quality is, but you can see it's starting to lay the first layer of our new base that we're going to be using. It's about a quarter of the way through the very first layer. Like it's a fucking going, man. It is printing. We've got it going. How long did it say? Like 14 hours. Oh, it ain't gonna be tonight. It'll be like tomorrow evening or something by the time it gets done. Like it'll be a while, you know what I mean? So reactor jacket, we're gonna put in 2 6mm. Okay. Do what? Okay. You just put mine in the microwave? Yeah, goddamn yeah. Right. 2 6 millimeter diameter holes for the temp probes. Okay. What else do we need? What else do we need? What else do we need? How am I going to secure this bad boy to the base plate itself? I think that might be where these nuts come in here. Nuts and bolts. I could use this guy. It's a 1/4 inch thick. I could do 3 of those through the hole and just put a rubber ring. But a rubber ring might mean it leaks. Or I could just glue it. That's something to think about. How we're gonna secure that bad boy on there. Okay, what other holes do we need? So we're gonna leave it hollow up top. So then we need a hole for the tubing and the tubing. The problem is I don't know what size my tubing is yet. I don't think I have any tubing. Actually, I do have tubing. I will BRB again. I'm gonna go grab that tubing. Or I can just go measure it. I'll be back. Okay. So the tubing is 6.5 millimeters in thickness. So that means somewhere here I need a 6.5 millimeter hole. The top will be fine. We'll design that into the top of the whole base plate. But we need a 6.5 millimeter tubing here. Is it a good idea to put it right next to the other ones? I mean, I could. I think I will, actually. Edit the sketch. And then we want to extrude. One X 6.5 millimeter diameter hole for water out tubing. And I'm going to make a note that says bottom hole so I can remember that it's the bottom hole. I think that's about it. Unless I want to save this as like a Rev 2. I could save it, do like a Rev 2, and then maybe like try to build the stilts up that'll hold the actual reactor in there. Right? Because you got your temperature sensor for the jacket, temperature sensor for the other one. Something else, Hattie, are the pumps something you have or ordering? I do not have any pumps yet. I'm gonna go to like Home Depot and get like one of the pumps for like the little mini fountains and shit. Just is gonna be like a little baby pump. Like it's not gonna be like anything super fancy. Like I'm not gonna go like crazy on the pumps. So one thing I gotta think about, Hattie, is how do I get this? So there's 32 millimeters after the wall thickness. There's 32 millimeters of the stainless steel that'll actually be inside the water. How do I get this guy through the jacket into the actual reactor vessel? That's something I got to think about. Because if I have this, say like partial of the stainless steel is in the reactor jacket and partial of it's in the actual reactor vessel, I'm going to have like really weird temperatures, right? So I got to be able to have this get through that hole and into the reactor, and only the stainless steel be in the reactor itself. So that's something else I got to think about, is maybe like I need to have this one, instead of it being like just a hole, have it be like extruded plastic somewhat, you know what I mean? Where like I can feed it through that extruded plastic and it's a negligible amount, hopefully, of heat difference and heat temperature difference, and then have it go in. Or I just have to wrap this in like something, but the problem is going to be how do I get it out? But if I have it as a plastic, if it's designed into the reactor jacket that it's like a plastic sleeve and I just slide this through the sleeve, then I don't have to worry about that, right? Because then if I just have my rubber ring on the cylinder of some kind. So this is my reactor, right? Re-explain everything. What up, Ant? So like if this is my reactor jacket and this comes in, right, like that, the jacket is going to be fine. I'm going to get all of my jacket temp, no issues. How do I get my reactor temperature and my jacket temperature to not be mixing unless I put in like a tube of some kind to where this is not touching the reactor jacket water, but it's touching the mixed water? So I think I'm just going to have to build like a tube in and then still have like the rubber seal and I just like push it through the tube, through the rubber seal, and just get it like leveled in there, right? And then it's in there and I'm only getting the temperature. Yeah, so if it's a little sleeve that goes in and then the probe goes in the sleeve, that's what I'm thinking. I think that's probably the best way to do it. And just make that sleeve, and if it's plastic, plastic doesn't transmit heat like super duper well, so I mean, it should be okay. That's what I'm thinking, is like this goes into the tube. So like this hole right here, I redo that extrusion, right? And I make it where it goes through the hole. That's kind of what I'm thinking. Also, what up, Ant? How you been, bro? So I need to try to redo that extrusion, right? You're in Disky? I need your help real quick, actually. And then I'm fixing to actually go eat. I got food that's waiting on me. I don't want my food to get cold. What's good, bro?
I got food. Good. I don't want my... Hey, so it might be kind of loud. I haven't got my headphones set up yet, but just got my computer set up. What are you trying to make?
Let me show it in the stream. These.
Oh, fuck. As soon as I turn my computer off. One second. Screenshot that, put it in Discord, please.
Where the fuck's my mouse? Alright, I put it in Discord.
Okay.
Now I can't find my mouse. Oh, that's because the snipping tool is all the way up there. It's fucking with my brain. So that means I need the thickness of the sleeve as well for that hole.
Okay.
6.5. So this sketch needs to be edited.
Switch
6.5.
What is this you're making?
Just like a little mini pilot plant. So your jacket temp is that hole straight through, right? So the jacket temperature is going to be the one that doesn't have like a little sleeve in it. It's just going to be this sticking directly into the side of it with like a rubber ring. And then the reactor temperature is going to be this 6.5 one that I'm working on right now. And I'll extrude it out through it where it's got like a little tube it goes in, and then it does the same thing on like a little rubber ring on the inside. And hopefully that makes it where my temperature's like solid.
What is your temperature difference going to be between the jacket reactor and your reactor?
I have no idea. That's why I'm doing this. I got to find out.
I would be. Are you 3D printing the pins going through?
Yeah, I'm 3D printing everything. I'm making this. I've already got the base printing right now. I'm 3D printing everything.
I might be, if it were me, I might be a little bit of concerned about temperature seeping through. Because if your jacket reactor, I imagine it won't be hotter than the inside of the reactor.
That's the point, is like I want to show that I can get cooling.
I gotcha.
Profile plane, join, distance, wall.
I would almost. I mean, a wooden pin with the temperature probe going through it would guarantee you wouldn't get any heat loss or interference, because wood doesn't translate well. It doesn't translate heat.
Right.
But then you would have to, machine the wood. That's the tricky part.
So I already see one thing I'm going to have to do here. I'm going to have to change the sketch because my math is off. Let's just do 20. 2mm thickness.
What's the third hole?
The third hole is for the water. like the actual
okay.
water. So this is the reactor temperature sensor that's going to go in. The second hole is for the actual reactor jacket, and then the third hole is going to be where the water comes out.
Also, if you can get to it, I don't know if you'll have access to it when you assemble it, but I would silicon that shit.
Oh, I'm going to.
Also, well, with them being stacked on top of each other like that, it might be hard to get to once the reactor is inside of the jacket.
So, my math here. This is the thickest part of this is 6.5 millimeters. So the hole needs to be 6.5 millimeters, but I did a 6.5 millimeter hole, but it did the wall thickness as part of that calculation. So if it's a 2 millimeter wall thickness, I need 10.5. That looks right. Where's that measure shit? This. Yeah, 6.5. Okay, I got it right. Good shit. Okay. So that's going to be the sleeve. Right?
Question. Why do your probes have to all enter and exit the same size?
They don't. I mean, this is just the way I was doing it. Like, this is kind of like what I was thinking of for like the first pass, is just have it like all on the same side, because it's like easy for me to like line up and do. So like this is going to be, this is the one that goes into the reactor. So it's going to go in this sleeve that's 2 millimeters thick. It's going to go in the sleeve, hit a rubber ring, and push into the reactor itself. And then the second one's going to be just a rubber ring around this, push it in, and then this is just going to be the water out hose coming out of the jacket. So this should technically be the hottest water, and then it gets recirculated back up into like a water reservoir of some kind.
Right. So what I'm saying, go back to the top, the extrusion you have going into the inside.
I don't know if this measurement's exact. I just made it 20 millimeters. I haven't put in the thought of like what size the reactor itself is going to be, because this isn't that big. This is, so after the clearance, I'm going to have like maybe 31 millimeters of like depth of like actually temperature sense and shit. But the idea,
I was just worried about assembly. Once you have all your pieces printed, is the reactor going to fit out with that big ass ball sticking out of the side? Like the length of that extrusion, you gotta get the reactor in there somehow.
Yeah. I mean, I can edit the extrusion. I just have it set to like 20 for like right now.
I understand. Okay.
So like now, so if I go back to my sketch, I've got all my inputs. The top, I'm gonna leave the top hollow and just like make one top for the whole thing. So this doesn't show it, but like the reactor and the reactor jacket are gonna be flush at the top, and I'm just gonna have like one lid that everything like feeds through. So the diameter, what did I make the diameter of this? So it's a 75 millimeter diameter reactor jacket. And I mean, these wires are like decently long for like what I need.
Yeah.
See, I was thinking about making it like all one piece, but I'm kind of worried of like trying to design the reactor inside of this. And like, cause it's gonna have to be on stilts or something, right? Because it can't be like the same, cause I want to have water through the bottom and through the sides, all like, so it gets a full cooling effect.
Right, but who's to say that it couldn't be a cone unless you want it uniform?
I just want it uniform.
I mean, okay.
I'm just trying, like, I mean, this is really like my first attempt of like doing something like this. So I mean, like, I'm gonna do like more stuff anyway. So I'm just kind of like wanting to prove to myself that it can be done. You know what I mean?
I mean, real talk, bro. I kind of like the idea of building. I mean, it's your shit, but I like the idea of building it all in the same self-contained unit.
Well, the problem is you're good at this CAD stuff, and I'm not.
It's not hard. I can walk you through it.
But I also, you got to think, like, I'm 3D printing this too, and so I don't want to make this super complicated.
It doesn't have to be. Actually, 3D printing it is one whole thing, and designing is one whole thing. It's probably your most simplified version.
Well, the problem is like the supports and stuff. Like, I'm gonna have to like try to get in there, and if it's all like attached, and I ain't got to worry about securing it, which is one good thing about doing it that way, is that I can build the supports up, you know, to hold the reactor like off the base of the reactor
Yeah.
jacket, and I can build it, and I don't have to worry about like gluing it or it coming apart. But how do I get in and like clean the supports out of that thing without breaking it?
Why do you need to clean the supports out?
Because you have to print with supports.
Yes, but why do they need to come out afterwards? Why can't they just?
Because
Stay
I mean,
there?
just because it would look clean.
You won't ever see it. It's on the bottom of it.
No, I mean you'll see it because like I want to show this to like people, you know, be like, hey, like it's like a conversation piece, right? Like kind of.
Cut it in half.
No, I mean like you can take the lid off and be like, hey, look, like this is what it looks like on the inside. That doesn't make any sense.
No, it doesn't. Where are the supports going to be? I'm thinking it just at the bottom of the reactor.
I'm thinking
bowl.
like a tripod. Like a tripod, and then like the reactor sits on top of like a base with the tripod like coming out, like just sitting into the reactor jacket. Is what I'm thinking.
Yeah. I'm thinking.
How the hell I draw that? I don't know.
I really wish I had a camera so I could show you some stuff.
Am I closing off that end as well? Off that end of the well?
I'm gonna
Off
draw
the
something
end
up.
of that well. Are you talking about this part right here, Eddie? Or are you talking about like the top? The top's gonna be open.
I'm sorry, James.
Huh?
I'm sorry, baby crying.
Oh, you're good. I can't hear it. Oh, the first one? No, I'm going to leave that open because that needs to be hollow, right? Because it's got to go into the reactor. I need to eat my food. My food's going to be cold. I'm like into the zone now. I want to like, I'm just going to like be staying up all night working on this shit.
Well, I'm gonna drop what I'm thinking you could do for your extrusions at the bottom for the 3D print. I'm telling you, I think it'll work.
Okay. Like in Discord or something?
Yeah, I might send it to you like Facebook, or I'm just gonna draw it. It's gonna be like really crude, so.
My problem is I don't know how to do like I can do like very symmetrical things in CAD. Our wells are closed off so the probe never touches the water. It reads the temperature off the well. So you're saying like you have like a stainless steel well or something, and you're just assuming like you don't have a temperature drop in between the actual probe and the water? Is that I kind of get the feeling that's what you're telling me. So you're saying like, I need a better camera, man. But like, this is gonna be blurry as shit. But like, you're saying this part here never touches the water, right? You have some kind of sleeve around it that has like a negative heat transfer, like difference, like you don't lose heat, and you're reading the temperature of that plate or whatever that is. It's actually in the water because the temperature. You're saying like if it's the same material and it's a really thin material or whatever it is, there's no temperature drop. I think that's what you're trying to say. So there's a slight drop, I would assume, yeah. But I mean, that's what you're saying, right? It's like this piece itself never touches the water. And the version I'm saying is like it goes in like a hole and it's in there that way. Correct. Okay, yeah. I'm not against that idea. The problem is the only thing I have access to is like a 3D printer. So it's like, how would I do that? Unless I got like some kind of like little stainless steel or tinfoil thing or something that like pops into this socket and just sticks out, and then the probe just like sits up against it. But I don't really know how to do that, or like where I would even get the materials for that, if that makes sense. Okie doke. Come on in. Also, if anybody else has any ideas, feel free to drop them in the chat. I will happily take some criticism and some ideas. This is just something that I didn't want to game, and I was like, I figured I would like do something nerdy and would try streaming it just to see if anybody was interested in watching something like this. I think it would be interesting to watch, but I'm also like the one doing something like this, so Diameter hole. Right, because we did a 2 millimeter wall thickness. Okay. Now the question becomes, do I just export this and call this good, or do I try what Ant's wanting me to do? I mean, in theory, it would be really simple. Instead of doing like a tripod, I could just do 4 and then have the bottom base, you know, conjoined to that 4. Unmute? Am I muted? How did I mute myself?
Yeah.
What up, guys?
So, you know how your reactor vessel is right now, right? How the bottom is closed off.
You talking about like the very bottom?
Yeah. Of your actual.
Like the vessel itself.
Yes.
Yeah.
So do the same thing with that well that's sticking out.
So the problem I'm having with that
would have that much of a drop.
Yeah.
Okay.
Because I mean I made it like 2 millimeters, so it'd be like pretty sturdy. 2 millimeters of that plastic, I mean, and having like this stainless steel thing in there, I feel like that would be a pretty big drop. And I mean, I don't mind having a rubber ring. I see what you're saying though.
No, yeah, I'm just saying that's how ours are. Like it's just a well that goes in.
Yeah, but yours isn't plastic either.
Correct. Yeah.
Yeah. So I mean, like, yeah, your heat transfer is going to be a hell of a lot better on metal than it would be with plastic.
That's true.
I'm trying to download Fusion right now so I can mock up what I was wanting.
Well, what if instead of a tripod, what if I just did like 4 posts and then
That's
just have?
I would do an array of like several different posts at the bottom of the fucking thing. That's what I was imagining.
Yeah, well, I was thinking of like them being angled. I don't know how to do that, but if I just make them straight up and down, and they're conjoined at the bottom of this plate, then they're not going to have to worry about breaking, and then I could just have the base of the reactor to sit on top of it. Right? And it would just all be like one solid piece. I think it's actually what you're trying to say.
Yeah, I want it to be. I would want it to be one solid piece because you're never going to see the bottom of that. The only place I would be iffy and wanting to get the supports out is where your bosses come in off of the jacket. You might have to support those and worry about getting the supports out there. But if you make the distance big enough in between the reactor and the jacket, you should have ample room. It's also going to help if you stagger them, like if you don't put them on the same side.
What does this do?
Like say you have a port every 90 degrees, like one for the temp, reactor temp, and then the water return.
Yeah, I mean, I should. Sketch. So, what would be easier for a 3D printer to print, circles or rectangles?
Does that make sense?
Yeah, it makes sense. Would circles or No, I can hear you. Am I muted again?
Hattie, you hear me?
Yeah.
I muted myself again. I don't know how I keep doing that.
No.
No, that makes sense. Which one's easier for a 3D printer to print, rectangles or circles?
Circles. If they're suspended, circles. But
well, I mean, it's just going to be like, you're going to have the base plate, right? And then you're going to have like circle structures coming up to be the support for the actual reactor inside the vessel. Yeah. So probably circles.
Yeah. That's what I would print. And it would help. It wouldn't, like any kind of flow of the water inside of that jacket. I don't know if that's important or not, but
well, that's why I made it circular too. Is like the water flow would be a lot better.
Yeah, it would. If they were square at the bottom, they'd disrupt it all. You'd get turbulence. As far as the bosses coming in on the side, the holes that you have coming in on the side, I would make those circles too. Just because once you get into a square overhang, you'd have to support that, and you don't want supports in the center of your flow packages or your sensor packages. I mean, I guess you could get them out, but you're talking what, 6 millimeters space?
Something like that.
Yeah, I mean, you could drill them out with a drill bit, but it would just be an extra step.
So I'm at 69. I don't think that's
nice.
Yeah. Yeah. So my bottom is 69 wide. 50 would be not bad.
For the inner, for the
Yeah.
reactor.
Yeah, that's what I'm trying to figure out is like how.
I mean, if you're going to want to get supports out from underneath the bosses or ports, whatever you want to call them.
Well, I'm trying to do like a base sketch on the bottom so I know like where the supports are going to go and then just not extrude this one just so I can like see where it's going to go.
You're just creating a template.
Yeah.
I would,
but I'm just trying to think of like how
I mean, you want to
thick
make,
I want this to be.
you want to make your supports go all the way out to the edge of your extrusion in the middle, because if not, it could potentially pull up on the outer edge. So you want supports all along that outer circle, that the circle that you're drawing.
Mm-hmm.
You would want staggered supports all the way around there.
Yeah, I mean, that's what I'm going to do. I'm just trying to figure out how thick, because this is going to be like how wide the reactor itself is going to be. Because that only gives me 4.5 millimeters on each side at 60.
I'd go more than that. You want more room than that.
I'm going to say like 50. 50 would give me 29 divided by 2, so like 14.5. So just about 15 millimeters on each side. That's not bad.
Yeah, it's what, 3/4 of an inch, a little under.
What about
I work
45?
I work in freedom units, man.
Freedom units. So if I did 45 millimeters minus 60, or 69 minus 45 is 24 divided by 2. So
That's about an inch. Yeah, I'd work with that.
I'd say that's good. I would say that's good. So that'll be my template. And now I just need to figure out how many supports I want to do and how thick of supports. So if I do a bunch of supports, I could do like 8 millimeter thick. I mean, that's not terrible.
No, I would do more supports smaller.
That's what I'm saying. So if I did 8, so this is 8, and I could do 8 millimeter supports and just do like a fuck ton of them.
Yeah,
That's kind of what I'm thinking.
man, I thought Fusion was fucking free.
It is free.
It's saying $85 for a month.
No, you have to go to like the right one, because that was telling me the same thing, and then I did it, and it was a lot better. Like you can actually get like the free version.
From Autodesk?
Yeah.
Free personal use.
I'm just gonna, yeah, that's the one you want. I'm just gonna throw supports kind of like all over the place here.
Hey, do you want a CAD mouse?
Do I want a what?
You want a CAD mouse? I have an extra one, like a Space Puck.
No, I'm good. I don't mind doing it this way. I wish I was better at CAD, so that's why another reason, like when Hattie was like, you can just drill the holes, I could, but I'm wanting to like design it as much as this as I can in CAD so I can get better at using CAD. Because I'm not the best at CAD.
I'll go ahead and let you know. Fusion is an okay tool for, just fucking around, but it's ass compared to like Inventor or NX. NX is king.
Well, I mean, I remember when we were in college, we used Autodesk Inventor, and it was amazing.
Yeah. But just for Inventor, I think for years it's like $4,000.
That is a lot of moolah.
So unless you know somebody with a student, email.
72 millimeters is how tall it is. And then we did.
You gonna constrain that sketch, buddy?
Am I gonna what?
Constrain that sketch. Put dimensions to those circles.
If I knew how to use it. That's the problem. Like I said, I'm not super good at using this. I don't really know what I'm doing.
I'm not gonna sit here and say that I'm the best. I have to fuck with it. I haven't used Fusion since.
Like anything that has like rounded edges, I'm just like the worst at trying to get like this shit to work. Like it's just giving me like all kinds of stuff. I think it's because I chose that one. I don't want to choose that one. Close it.
There should be a tangent command. You can also search your commands. There should be a search bar up top.
Just tell me how wide that is. You know what? Fuck it. We're not going to worry about it. Anyway, so it's 72 millimeters from the bottom of this to the top of this. So that gives me 72 millimeters of play. And it has to be, the reactor has to be flush with the top.
Yeah.
So how tall do I make these supports?
I would try to make them at least half the distance between your reactor and your jacket. At least.
And that's 12 millimeters.
And with them being raised like that, you're more than likely going to have to move your ports in from the side. Or ports up, sorry, not in.
Yeah, that's why I was thinking this one might have to move up. So 72. So let's do an extrusion. We're going up. Let's do 10.
So, go center. James, what's the diameter of yours in freedom units?
I have no idea.
What's the diameter in millimeters? I'll do the conversion.
Of what?
Of the jacket. Inner and outer.
75 millimeter outer, 69 inner.
Nice.
Nice indeed. What is this distance we do?
Oh, you're almost 2 inches. Damn, that's kind of small.
I mean, it's not going to be big. It has to be 3D printed. What did I do? 45? Yep. So that's 10. Oh, that'll definitely fit. So I did 45. So 10 would be, what I said, 72 to the top?
Yeah.
So 62. Wait, what is it doing? Wait, is that one a different thickness?
What?
This one right here.
It looks like you're extruding that circle you put around those, not the actual.
Well, I'm trying to do the actual circle. This top one, but it keeps saying like that one is part of it.
There's that. Create another sketch.
Isn't what I want to do at all.
Oh, how do thing?
See, now I also don't know how to like look and see. So why is that?
So James, you don't want to extrude that outer circle yet
Why?
because you fucked it up. Delete that inner circle extrusion, or the whatever, the extrusion covering up all your support.
Okay.
So now you would really want to either extrude from the top of those pins.
That's what I was trying to do.
Yeah, so you're going to have to create a new sketch and make the datum you're playing the top of those pins.
That's what I was trying to do. I think I did it off the bottom though.
Yeah, so you can do it one of two ways. You can either create a new sketch, put it on the top of the pin, and then draw your circle. The problem is if you're going to have to pick the center of the drawing, not the center of one of those pins. Like, the center of the X and Y plane.
Can I not just do like new sketch and then just hit this top one? If I chose the right one?
Is it in dead nut center of your whole drawing?
Yeah.
Then yeah, you should be able to.
Now do finish sketch.
What plane are you on? Are you sure you're on that? I can't really tell. I've got you on my side screen.
XZ. I think XZ.
Yeah, okay, that sketch is at the top now.
There we go. 62. Not cut. Join.
Well, because of that boss, it's thinking you want to cut away.
We'll do 1 millimeter thick walls. Yeah, I mean, that's right.
Only a mil thick
Well, I gotta have heat transfer, right?
from the inside to the outside.
Well, I gotta have the inside be cooled by the outside water.
Yeah, I'm not in disagreement with that. I'm more worried about the porosity of the plastic seeping water.
How do I edit an extrusion?
Down at the bottom corner, left corner. Bottom left corner.
Edit
Those
feature?
are your playbacks.
Oh.
So that's like your history tree, in a sense.
So I'll do 3 millimeters thick then. Three is too much.
Yeah, it's going to be tricky either way.
I will do 1.5. Yeah, 1.5. So now I just got to get the base. The base. $45. I did 1.5, so that's 3. That's 42. I'm doing this like the most complicated way possible.
Your supports being non-symmetrical are fucking with me.
You said just put them random.
No, not random.
Well, I'm keeping them random. I mean, I think that looks pretty good.
What size are those support?
8 millimeters wide, and then 10 millimeters high. Is there a way to slice this so I can like see through this wall?
Yeah, go to surface, I believe. It's either surface or utility.
Where would surface be?
Up top in your menus. Scroll through those. No. Right, go right. No, too far right. Damn it. Go into the modify tab. You're muted.
I'm not muted.
Let me read. Stop. Please stop. God damn it. Stop clicking.
Well, I had to click off to do that.
Alright, go to utilities. Scroll over some of that shit. I forget you're looking for something called like section or section view.
Section analysis?
Yeah, maybe. I don't remember what it is.
Creates a view that cuts through all visible objects in a design to reveal interior details.
Yeah.
Okay, so how do I use that?
Well, click it first. Alright, so now you're going to specify your cut plane. So stop clicking shit. So you see those yellow planes in the center of your whole drawing?
Yeah.
Roll around. You can click one of those. You should be able to click the plane, and it should give you an option to drag it.
Oh.
Should.
There we go.
Yeah, so there's arrows at the bottom that allow you to drag the plane.
That looks... I am very happy with that, actually.
You're going to have to fix those pins.
Nah.
Yeah. You're going to wish you did. Like, bro.
Oh, hold up.
Yeah, there's a clear that hole in the middle.
Yeah, I'm gonna have to re-extrude it. How do I get out of this view?
Might have to go back to section plane. That I'm not entirely sure of. Go back to that command. Section analysis.
Can I just like Control Z? There we go.
You could.
So that hole. So those two are hollow. This one is not hollow, so I need to change that extrusion.
Honestly, go to the surface tab. I think there's just like a delete face or delete surface. You don't have to do that.
I mean, I could just do this one and do cut.
No. Because then it'll get rid of your tube in between the jacket and the...
See, now I gotta check it again because I don't think I did it right. I did not. So like you're saying if I just like click it, there's like a way to delete surface?
Yeah, so no. Go to the surface tab up top. Surface tab up top. There you go.
Yeah, I'm
a little bit behind. No, it's not. Go to create. Or no, modify. Go to the modify tab. Hit the drop down and modify.
delete.
No, you don't want to delete it. Oh, it might. Go ahead. Hit it. Go ahead. Plug it. See what happens. Hey, yo.
Did that do what I wanted?
I believe so.
Yeah, it did. Okay, yeah. Cool.
Telling you, James, I'd make those post 4 millimeters. I'd have them evenly spaced. I'd have one in the center like you have it. I'd have as many around the outer circle, and then split the distance in between.
I mean, just for like a first pass though, like I feel like this isn't that bad. You're good, Hattie. No worries.
Wasted plastic, bro.
I mean, this is my project, you know. I'm just doing it. Just trying stuff out.
Trying to help, brother.
Brody. I mean, I'll get there eventually. I mean, it really wouldn't be that big a deal to move that one. Which sketches that.
Yeah, but the further you get out away from the edge, all that unsupported material in between. Granted, it all looks bigger in CAD, but that's still what.
I mean, it's also 3 millimeters thick though, so I mean, like that's gonna be pretty solid. And it's just holding water. Like I don't think it's gonna like break.
It's going to be solid, but what about your first 2 layers? They're gonna droop, and then you're worried about porosity. The more it sags, the less sealed it's going to be. Yeah, it's just. Your project. I'm eager to see how it goes, though. Let me know.
Yeah, me too. Now I got to figure out how to get it back to where it was. Well, I just went back. Like, how do I get it back to where it was?
Unsection it.
Surface delete. Yeah, how do I unsection it?
Go. Hold on. What do your buttons at the bottom do? The menu buttons at the bottom, like middle of the screen bottom.
Look at, orbit, pan, zoom, display settings, grid and snaps, and then viewports. I don't think that's anything I need.
No. I guess go back to the utilities and try to unsection it. So you have a cut plane selected. So instead of instead of selecting another plane, you can hit the X button up in the menu to your right. See the little X next to where it says one selected. To your right, your other right. No, not that.
I clicked it. I mean, I could always do section analysis and then just drag it to where it's not in the way.
Yeah, but it doesn't get rid of the section.
Yeah, but I mean, then I could always go in and look at the section analysis again and then have it like fixed.
Do me a favor. I want to see something. I'm learning with you at this point because I don't know how to do this. Can you go back to that?
The section analysis?
Yeah.
Looks cool. I know nothing about reactors. Me neither, Hetty.
Hold shift and select the plane that you. Yeah, hold shift and then select that plane.
Hold shift. And select the yellow plane?
Yeah, or control. If it doesn't highlight, control might do it.
Okay.
Or not the blue plane at the bottom. The one
doesn't.
Neither shift nor control did anything?
No.
Okay, well, never mind. Fuck it. Do what you've done. There should be a way to deselect all that without having to drag it off, because that just seems like a...
There's definitely a way to do it, I just don't know how.
Yeah.
See, I mean, I think that's pretty good for like my first try of designing something. And just kind of like fucking around with it and doing some design work. And I'm down to keep going, I just gotta eat, because it's 8:30. I would really like to eat dinner. So, I mean, I could always just leave the stream running, I guess, and come back in like 20 minutes after I eat.
Good job, James. I give you a C-.
Thanks, man. It's something. I mean,
I'm just fucking with you, dude.
I'm just wondering if I should make the supports taller. Which sketch is it?
I would have made him half the distance of the
I mean,
walls.
I mean, that's 12 millimeters. So I mean, they're 10 tall. So I mean, it's 3/4.
Yeah.
Hell yeah. I do need to change that, I feel like.
Hey, what? I'm lagging.
That extrusion.
Why?
Because it's sticking like into the reactor itself.
You might get some turbulence there, but I don't think it's a huge deal. I mean, you're going to have a probe sticking out of it anyway, so it's going to disrupt the water.
Yeah. That's a little bit better. It's not as far out there. Cool. Yeah.
You could do some surface work and just make it flush if you wanted to. Surface tab.
How do you do that?
We're gonna learn together. I just know that that's a thing you can do.
Trim?
Yeah. Selector, service bodies, yeah. So you should be able to select the end of that.
It just gave me an error. I don't know.
Yeah, selecting the whole body. I guess where it's all connected as one, it's considered as a whole body. And there needs to be like a trim face feature. I don't know if this has it. You'll probably have to split the face and do a bunch of fucking shit. Like split body command right there. That's probably what you have to do.
I don't know. I ain't worried about it. Now it makes sense seeing it. Now I see what you're doing with the probe. Oh, okay. Yeah. Yeah, hopefully that makes more sense now.
Hit me up when you do the lid.
Will do. Section.
Yeah, I got my computer set up, man. We need to hop on some games when Hannah allows it.
I'm down, bro. Just whenever.
I really want to try. What's that new game that's like Call of Duty Battlefield combined into one?
I did the wrong face.
It just came out not too long ago. I want to say like Delta Force, but I don't think that's what it is.
I'm so fucking psyched about this. You're a visual learner. It's all good. Dude, I'm so psyched about this. Like, this makes me really happy. Because I've never had like the ability to like do something like this now, and like now it's like anything my brain can think of. Like if I could measure it out, I can do it.
Like a tournament trophy.
Yeah, that you were supposed to do 4 months ago.
It's so good. Dude, I had life, man.
Nah, I get it. I'm just fucking with you.
I swear to God, I started it on my computer at work, but I don't work there anymore. So.
That's fair. Is there anything else I want to do this right now? I don't think so. I think I'm going to call that good on that one for right now. Cool. Just curious, if I export this as an STL, what does Cura say? Like, how long does it say it's going to take? I'm just kind of curious.
I think that print's going to take forever.
100%.
Need a new printer. God damn it, what's the name of that game?
7 hours and 10 minutes.
Not bad.
The highlighted area indicates either missing or extraneous surfaces. Fix your model and open it again in Cura. Oh, so it can't, like, it doesn't know what to do with that little section.
What little section?
The section I deleted with the thing you was telling me to use.
Oh, the surface tool?
Yeah, it's like I don't know what to do with it.
I mean, the only thing you can do is go in and extrude the same diameter and cut it out that way. Yeah, go to where it starts that layer. Go down. Whatever. Zoom in on how it's filling that.
I don't see what's wrong with how it's doing it.
Me neither.
I mean, it's saying it can still do it, so I mean, like, yeah, I mean, that looks fine.
Did it? What about where your supports are at the bottom? How much filler material did it use? Like at the bottom of the jacket.
Yeah, that's what I'm looking at. Oh, the bottom of the jacket, nothing, because it's just level with the plate.
No, that's what I meant. The fucking reactor core, whatever.
A lot, because it has to like build up that first layer.
Yeah, that's what I was worried about. Is there a way that you can force it not to?
Jenna knows how. I don't know how. So I mean, I could ask her before I print it.
Well, that's kind of why I was suggesting doing more with slightly smaller diameters to kind of take up more space, where you could use less support.
If this works out, bro, this is gonna look sick. Okay, it's 8:30. I'm gonna go eat food.
Really, man. Nice talking to you.
Hell yeah, brother. Anytime, man. Anytime.
If I find that game, I'll let you know. It's free to download.
Yeah, that's fine. I was telling Jenna earlier, I was like, I don't really have a game in mind of like what I want to play. I was like, that's kind of my problem right now. It's like, what do I actually like want to play?
Black Ops 6, bro.
Oh, I'm gonna play Black Ops 6. So I'm just saying, like, we have 2 months until Black Ops 6.
I know.
So it's like, what do I do until then?
Round war.
Ground War?
Yeah.
Yeah.
Dude, hey, yo, let's get 6 days of Fallujah.
What is that?
6 days in Fallujah. It's like a fucking Afghanistan war game where like the enemies spawn at random locations every time you play through. It's a constantly switching environment. They learn, like it's
That sounds
sick
cool.
game. I don't know how much it is right now. It was like $40 though. I don't know. It's kind of steep.
For a game we might hate, yeah.
Yeah. Oh, we won't hate it. I have a feeling we'll like it. It's just once Black Ops 6 comes out, you know, we are probably never going to touch it.
Oh, I mean, we're 100% gonna be like on Black Ops 6 the second it comes out.
Yeah.
I'm trying to think what else I need to design. So I got the main reactor and the reactor jacket. I got the base. I need the water reservoir, but that'll be easy. The top is going to be the next hardest piece.
Yeah. I mean, the top, you can literally just create from that. Just create you a new component and then have like grooves in the top that you can, that like fit down into your.
Oh,
my legs.
My legs. Yeah, it makes sense. I remember doing that at college whenever we were going to college together. We were actually in the same class too. Woo.
And you didn't learn shit.
I did. I mean, I've learned something. I mean, I just built this, bro.
Yeah.
All right, well,
Fairness, this is what I do. So.
yeah, this is literally what you do for a living, bro. I don't do this shit.
Yeah.
I'm just doing it for the funsies, man. And I am totally gonna print this shit after the other one gets done. And I'm home all day tomorrow. Let's go.
Nice.
right.
Go eat.
That's the plan.
Yeah.
0. So I think we've made pretty good progress. Anybody that's out there watching, that's like the cross section of it. You know, overall, this is what it looks like. Takes about 7 hours to print, and we've got our reactor jacket and our reactor itself. Next, all we got to do is do the base. Not the base, sorry. We got the base printing right now. Is the top of this, the water reservoir. You'll be at work until 1 my time tonight. But I'm thinking about maybe streaming it again, but I just want to go eat. So like maybe take like a 30-minute break or something, like in the stream, take a 30-minute break, come back and like restart the stream. It's kind of what I'm thinking. I'll be at work till 1 p.m. my time tomorrow. Okay. Wait, so you're at work right now until 1 p.m. tomorrow, or am I just dumb? I'm confused. I'm so proud of that. I really am. I know it's like nothing and it's like super basic and like super easy, but that like this like just being able to do this and like see that cross section thing, that honestly like has made my like night. No, I go in at 5:30, be there till 2 my time, but it'll be 1 p.m. your time. Oh, so you're fixing to go to bed then, because it's like 9:30 your time, 9:40. Well, have a good night, my man. Honestly, don't know. I mean, like it's 8:30. I might just watch TV and say fuck it and go to bed at some point. But I also kind of want to keep working on this, so I might. You stay up late, bet. Yeah, I might kick it back on after I eat. But I really want to eat my taco mama because it's probably cold by now. She gave it to me like an hour ago. So I'm gonna end the stream. GG's everybody. Thank you, Hattie, for hanging out and giving me some feedback on stuff. And yeah, I'm gonna end the stream and go eat, and then I might kick it back up here in like